Hello friends. Today we are going to talk about linear equations in one variable. So how are we going to do this? Right? So um, let us learn where we are going to use one variable here and what are linear equations. We are going to learn all about this in great detail. So let us start. So let's first have an introduction as to what it means when we talk about linear equations as well as algebraic expressions. So what is the difference between an algebraic expression and an equation? Now look at this example. 2x plus 3, x square plus 1. If you can see in both these kinds of expressions, there is a variable x, x square, right? But there is no equality sign or an equal to sign present here. Such kind of expressions are known as algebraic expressions. Now let us see the next example. 2x equals to 10. Now here you can see there is a variable x as well as an equal to sign in between. Another example, 5y minus 2 equals to 4. So this is a typical example of an equation, okay, where you can actually see that there is an equal to sign or an equality sign in between, and you have some expressions onto the left hand side and some numbers onto the right hand side. So this is a typical example of an equation, whereas in an algebraic expression, as you can see, there is no equality sign in between. Equations, remember, always have an equality or an equal to sign between which this is not seen in expressions. So algebraic expressions and equal to or equations have this difference, right? Now let us learn more about this when we talk about further. We are going to learn about how we are going to apply these variables and linear equations. When I talk of a variable, it means anything which is going to vary, which is going to change. So what is a variable? It is any quantity which can change. And we always express it in the form of alphabets, generally in the lowercase, like X, Y, A, B, P, and so on. So you have to understand, if in a particular equation, I get the value of X as say 4, it does not mean that for every equation, x is going to have that value of 4. That is why we call it as a variable. It is going to change with each equation depending on the equation. That is why such alphabets which we give, we call them, such expressions, we call them as variables. So what is a linear equation then? Linear equations are also equations which will have only one variable. Any one of these alphabets will be there, and the highest power of that variable is going to be 1. For example, 2x minus 3 equals to 7. So if you see, the variable here is x and its power is 1. This is exactly when we talk about linear equations, this is what it means. So let me see another example. X square plus 1 equals to 4. If you can see here, there is definitely one variable here, but if you see, there is the power is more than 1, that is 2. So that means here you can see, you cannot call this as a linear equation. So this is how we can actually make out the difference between linear equations and equations which are not linear, right? So this is how we work on these kind of problems. Okay. Now let us learn more about linear equations in detail. The same equation, 2x minus 3 equals to 7. Now in this equation, you can see that there is a part of an equation which is to the left-hand side of the equal to sign. So I'm having this part which is to the left-hand side of the equal to sign. I will call it as the left-hand side or the LHS. So similarly, I have some number to the right-hand side of this equal to sign. I will call it as the right-hand side or RHS. So what we understand is that in any equation, a linear equation, we will have an equal to sign, right? But there will be some numbers, a variable, something to the left-hand side and something to the right-hand side with the equal to sign in between. And if we have to find a solution, finding a solution means we have to find the value of that variable. That variable might be any alphabet. We have to find the value of that variable in such a way that both sides are going to be equal. That means in this equation, a value of x will have to be found in such a way that when I substitute that value of x in this particular equation, both the sides should come out as equal. Only then can I say that my equation or the value that I have found out is correct. So this is how generally it works for us, right? So let us move ahead and see how we are going to go ahead and do this, right? Now let us solve some equations. I have taken that same equation, 2x minus 3 equal to 7. Now I want to find out this variable value x, right? So I will keep it as it is on the left hand side and I will take this whole number to the right hand side. Now you have to remember when we take any number or a whole number to the other side, it might be from left to right or from right to left, the sign changes, plus becomes minus or negative becomes positive. That is one thing. If it is multiplication on this side, when it goes to the other side, it becomes division. If it is division, when it goes to the other side, it becomes multiplication. So here you are having minus 3. So 2x, I'm maintaining it on this side, equals to 7 plus 3. Now this minus 3, when it has come to the other side, has become plus. So what am I getting? 7 plus 3 gives me 10. So 2x equals to 10. So x equals to 2x means 2 into x. So x will be, this is what I have to find out. So x equals to, this 2 when it comes to the other side becomes division. 10 divided by 2. 2 ones are, 2 fives are. So I got the value of x as 5. Now we have to check it out. Is my value right here? Please understand, x is the variable. For this equation, the value of x is 5. But it is not necessary that for every equation the value is going to be 5. So let us check. So I'm substituting the value on the left hand side for x. 2 into 5 minus 3. Let me solve this. 2 into 5 is 10. 10 minus 3 is 7. So on the left hand side I got 7. Right hand side it is already 7. 7 equal to 7. Left hand side equal to right hand side. That shows that my particular value that I found out is correct. So it is always very good to check out your values beforehand itself, right? Okay, now we will be moving ahead now. All right, so let us move ahead with another equation. This is an equation with fractions. Okay, so it is 15 divided by 4 minus 7x equals to 9. So now what am I going to do? I'm going to keep my variable to this side itself. So I'll maintain minus 7x on my left hand side. I will take this 15 upon 4 to the right hand side. So here it is plus the value, the sign. When it goes to the other side, it is going to be minus. So it is 9 minus 15 by 4. What does this mean? On the right hand side, I'm having 9 upon 1 minus 15 by 4. Now I want to solve this. Best way is to take an LCM. LCM is going to be 4. 1 fours of 4. So it is going to be 9 into 4 minus 15 into 1. We take it that way. Okay, so it is 36 minus 15 by 4. So I'm having 21 by 4. So minus 7x is equals to 21 by 4. So x is going to be, I'm taking this minus 7 here. So what is it going to happen? 21 upon 4 into minus 7. It comes out to be 21 upon 7 fours are 28. So minus 28. So I'll take the 7's table. 7 threes are 21, right? 7 here, 3s are 21. Let me just take that. Yes. 7 3s are 21 and 7 4s are 28. So it is going to be 3 by minus 4, or we can take it as x equals to minus 3 by 4. Let me try to substitute it on left hand side to check. Just 15 by 4 minus 7 into minus 3 by 4. Okay, so what is this going to be? 15 by 4, and this is minus 7 into minus 3 is plus 21 by 4, right? So what is going to happen is I will get the common denominator here as 4. So 15 plus 21 It's going to be 36 by 4. 4 ones are 4 nines are. So I'm getting 9 on the left hand side equals to 9 on the right hand side. Left hand side equal to right hand side. So I'm getting
Hello. Yes.
So we have found out that yes, the value is perfectly correct. So just by observing, you can see that our LHS is equal to RHS. So yes, we are getting it correctly. Okay, so now we are going to actually see further, right, how we are going to move ahead with that, right? Let us take an example in the form of the exercise that we are having. Okay, so let us see how we are going to go about it. Right. All right. This is 6 sum exercise 2.1 I have taken. Sum number 6. T divided by 5 equals to 10. Here the variable is t. We have to find out that value. Now t upon 5 equals to 10. That means 5 from division. When it goes to the other side, it becomes multiplied. So t equals to 10 into 5. That is 50. So let us check by putting this value of t in the sum back. So it is going to be left hand side 50 divided by 5. 5 ones are 5 tens are. So I'm getting it as 10. So left hand side 10, right hand side 10. LHS equal to RHS. So yes, this value of 10 equals to 50 is correct. Another sum number 11, 17 plus 6p equals to 9. So what am I doing? I'm keeping my variable to my left hand side as it is, and I'm transposing this whole number to the other side. So what do I get? 6p equals to 9 minus 17. So 6p equals to minus 8. P equals to minus 8 divided by 6. This will go by the table of 2. 2 fours are, 2 threes are. So what do I get? P equals to minus 4 by 3. Let me just try to find out whether I'm correct. So on the left hand side, 17 plus 6 into minus 4 by 3 gives me 17 minus 24 by 3. Let me take this 3 as the LCM. Okay, so it is going to be 17 into 3. It is going to be 51 minus 24, right? So it is going to be 17, right? It is going to be 51. How are we going to get this? 51 minus 24, right? So it is 11, 7, 27. So 27 divided by 3. 3 ones are, 3 nines are. So I'm getting 9 on the left hand side equals to 9 on the right hand side. LHS equals to RHS. So whatever I have done is correct, right? So the value of P in this particular sum is correct. Okay, so now let us move ahead and see some more applications, right, of linear equation. Let us go through some sums that we can learn, right? Okay. All right. So the perimeter of a rectangle is 13 centimeters. Its width is 2 3/4 centimeter. Find the length. So we don't know the length. There is a rectangular area, right? We don't know the length, so we'll take the length as x. We know the breadth. It is 2 3 by 4 centimeters. So let the length be x because that is what we have to find out. We know perimeter is 2 times length plus breadth. So now I'm just substituting the values. Length is x, breadth is 2 3 by 4, 2 times equals to 13. We already know perimeter is 13. So now I'm going to solve this. 2 3 by 4. 4 twos are 8 plus 3 equals to 11 by 4. So I'm putting that value 11 by 4. I'll keep the bracket as it is. When this 2 comes on the other side, it becomes division. So x plus 11 by 4 equals to 13 by 2. Now I'll take this 11 by 4 to the other side. X equals to 13 by 2 minus 11 by 4. So what is it? 4 becomes my LCM. So 13 into 2 minus 11. So it is going to be 26 minus 11 by 4. So that is going to be 15 by 4. If I convert it, what does it mean? 15 divided by 4. 4 threes are 12, right? So you're getting 3 here, 3 by 4 centimeters. So this is exactly the breadth of the particular rectangle that we have. So by just taking the length of it, breadth is already given or width was already given. So through the perimeter, we have actually found out how we can actually come to know the various parameters just by using the values that we have. Okay. Let us learn about some equations with word problems. Okay. The present age of Sahil's mother is 3 times the present age of Sahil. So we do not know the present age of Sahil as well as his mother. They have said, so we are going to take Sahil's age, present age as X years. So what will be Sahil's mother's present age? 3 times that, so 3x years. We've talked about after 5 years. We know whenever we talk of any years later on, we just have to add it to our present age. So if I'm 30 now, my present age is 30. 10 years from now, I'm going to be 30 plus 10, that is 40. So for them, after 5 years, what will be Sahil's age? It is going to be X plus 5. The present age plus 5. So his mother's age too will be the present age 3x plus 5. And they've said after 5 years, their ages will add to 66. So addition of these two ages is going to be 66. X plus 5 plus 3x plus 5 equals to 66. Now I'm going to take the two x's together. X plus 3x gives me 4x plus 5 plus 5 equals to 10 is equals to 66. I'll maintain 4x on the left hand side and take 10 to the other side. 66 minus 10. So x will be 56 divided by 4, which is 14. X was Sahil's age. So Sahil's present age is 14. So what will be his mother's present age? 3 times of 14, 42 years. Easy, isn't it? So it becomes very easy once we know how we can actually apply the linear equations to all our problems. Now I'll try to solve an equation from our the exercise. Okay, that is exercise 2.2. Let us take the second sum. The perimeter of a rectangular pool. Again, you are having a pool which is rectangular in shape. Okay, the perimeter has been given as 154 meters. Its length is 2 meters more than twice its breadth. That means we do not even know the breadth, nor do we know the length. So let us take the breadth as x. If I'm taking the breadth as x, the length they have said, it is 2 meters more than twice its breadth. So twice its breadth is going to be 2 times of x and 2 meters more, so plus 2. So length becomes 2x plus 2 and breadth we have taken as x meters. Perimeter we know is 2 times length plus breadth. So we just substitute the values of length and breadth in this particular equation. So I will get 2 times 2x plus 2 plus x equals to 154. So here 2x plus x makes it 3x. So 2 times of 3x plus 2 equals to 154. Now I'm taking this 2 to the other side. From multiplication, it will become division. So 3x plus 2 equals to 154 divided by 2. That is 77. Let us see. 154 divided by 2. 2 sevens are 14. 1, 4. 2 sevens are 14. So 77 is the answer. So 3x equals plus 2 equals to 77. So 3x is going to be 77 minus 2, which is 75. So x is going to be 75 divided by 3, 25 meters. So what is x? Is the breadth. Breadth is 25 meters. Length is going to be 25, 2 times of x plus 2. So 2 into 25 plus 2. 50 plus 2, 52 meters. Isn't it simple? So this is how we can actually go about with all these sums. It's become so easy. Just if we know even one of the parameters, we can actually find out the other, right? So this is how we have to work, all right? This is how we are going to use our linear equations, our idea about linear equations Right. Now we are talking about another age sum. 15 years from now, Ravi's age will be 4 times his present age. That means we do not know his present age, so we are going to take his present age as x. 15 years from now, that means from now 15 years, which is going to be x plus 15. Simple. They have said that 15 years from now, Ravi's age will be 4 times his present age. So 15 years from now, x equals plus 15, his age will be equal to 4 times his present age, that is 4x. So what am I going to do here? I'm going to take the variable to the other side. Otherwise, if I have taken 4x to this side, I would have had to take 15 to the other side. It would be double the operation. So let us just take the variable to the other side. I get 15 equals to 4x minus x. So 15 equals to 3x. So x will be 15 divided by 3. 3 ones are 3 fives are. So I got x as 5 years. And what is x? It is Ravi's present age. So that is what has been asked, right? So isn't it easy? The present age so clearly and easily we have been able to find out. So you can see that from this, from by carrying out various just important thing for you is to get this equation. Once you're able to get this equation, everything is so easy, right? So try to solve the sums. There you can use these linear equations even to learn about denominations, currency notes. Everything is so easy. You just have to try to get it into the form of a